figuring out who done it, how a local school is training tomorrow's forensic experts to solve the case.
And picking on the president.
On the next New Hampshire Chronicle.
Tonight at 7:30. Every single detail counts. When someone commits a crime, it takes a detail-minded group of investigators to piece together what happened.
To become a crime scene investigator is a rigorous process, too. A process now being offered at a local college.
See what it takes to find out who done it. When you think CSI, this may be what you envision. But the reality is far more mundane.
And it's not for everybody. I think what draws people into our program is they see CSI and they think it's all glamour and it's going to be a lot of fun. Then they take a fun class from Dr. Petersen, and again they say, oh, this is going to be a lot of fun. But the job itself of being a forensic scientist it's a science job. It's very detailed and painstaking, exactly as you said, and it's not for everybody.
Dr. Cheryl Petersen is helping train the next generation of forensic scientists at Hesser College's new forensics lab. Lesson number 1.
Forensic science is really kind of a boring job unless you like looking at things under a microscope. So it's very glamorized on CSI.
Dr. Petersen might not make the job sound glamorous, but ask her students about the class and they're riveted. This isn't your typical lecture.
It's awesome because she's so interactive with the students. It doesn't make it boring. It's interesting. She'll be lecturing and, you know, bounce up, jump on the table, keeps your attention. It makes you want to learn, and it creates a nice learning environment.
Part of that nice learning environment includes examining blood spatters, a lesson that always gets the students out of their seats using fake blood.
I got this at Walmart, but it does have the same texture, and it's a very realistic blood, but it is washable.
Remember, it's me in midterms.
And I think in their heart of hearts, especially if we do the fake murder around midterm or final exam time, I think they picture me there as the victim, saying, yes, that's for all that work you made me do. But it is a lot of fun. The convergence area of the strings shows you about the approximate place that the victim was when they were bludgeoned. So right now we're getting the idea that our victim was here. And again, this is part of crime scene reconstruction.
Dr. Petersen measures the width and height of a blood spot and calculates the fraction that will tell investigators where the victim was and the angle of impact. It's a murder by numbers.
You can use this kind of fancy protractor, which is sort of a grown-up version of something that every kid knows from high school. This space in here is an 18-degree angle, which the students kindly cut out for me, and it fits right there. So that angle goes here, here, and that's the angle that the string gets strung at. So now instead of lecturing about these deadly dull formulas about, you know, width over arc sine times width over length, now give me my angle, now I can show it to them and they can see how those, you know, angles relate to an actual diagram of where the victim was injured. So I think it breathes life into it, and for people, and I think this is true for a lot of people, you can hear about it, but until you have to apply it, it really doesn't always gel.
Blood splatter analysis is also used to teach students direction of travel.
The reason we do blood splatter analysis is to kind of reconstruct the scene, to see where people were, what direction they were traveling when they left the little blood spots. This is called a satellite because it's a smaller drop of blood that was flung from the other. So you have these spines that are actually part of the blood drop and a satellite that is a cast-off from it. So if it's pointing in this direction, the person was running in this direction.
Soil sample analysis, another way investigators can help solve crimes.
What we're doing is we're shaking this up so that the heavier particles sink to the bottom, and that's always going to be sand. And then the lighter particles are going to float.
The students mix soil and water in a beaker into what Dr. Petersen calls a soil slurry.
This is why I never can keep a manicure. Put your heart and soul into that.
All soil is comprised of silt, clay, and sand. The separation of the particles creates what looks like bands, and the percentage of bands becomes a mathematical equation, a numerical way to compare different soil samples.
These are the radial fracture lines, and these are concentric lines.
Another learning lab, the forensic analysis of glass. The first part is fun. You get to break the glass.
You feel up to it?
I don't know. I'm
Do you feel mean?
Say something mean to me. Okay.
Okay.
And I'm just right there?
Yep, right there.
It's not like 7 years of bad luck, is it?
Uh-huh.
That's me.
Yes,
So
it is, but don't worry about it. Yay! I love that. You were good. That was, did you feel
was
good?
good?
Yeah,
Yeah.
very therapeutic,
Could I have
isn't it? No.
Then the pieces are collected and measured.
Mass is typically interpreted to mean the weight. We're going to weigh this little fella. And he weighs 0.98 grams. So that's our mass.
A hands-on way to teach students the science that could solve a crime.
I love the hands-on. I love being able to learn about processing the crime scene, like, for instance, the blood splatter analysis, how to tell where a victim was, where the criminal was standing, etc. It makes it intriguing.
So this has been wonderful for me. I get to laugh, I get to have fun. The kids laugh at my little corny jokes. And I think it makes the hour and 15 minutes that we're together go by much more pleasantly.
Coming up, picking on the president.